All right, so lesson 41 is Introduction to Polar Coordinates. All right, so it says the graphs you've learned so far in all of your math classes have been in the Cartesian coordinate plane. Fun fact, do you guys know who the Cartesian coordinate plane is named after? That is correct, Lauren Bouncel. Good job. Math history fact of the day. Rene Descartes, the guy that said, I think, therefore I am. And do you guys know how he came up with the Cartesian coordinate plane?
Oh, it was like flies.
Yeah, so he was laying in his bed and he looked at his ceiling and it was just like this ceiling that has this grid on it, and there was a fly that was bouncing around, and he was like, I wonder if I can figure out how far that fly has traveled. I don't know why. Why do people think these things? And he came up with the Cartesian coordinate plane that we use all the time. All right, anyway, so this is a simple grid with squares. But what if we want to graph something more complicated? So what if I want to talk easily about distances from the origin, like the distance that a satellite transmits, like north 60 degrees west, things like that. So in many instances, it's useful to learn polar coordinates, so kind of a circular coordinate plane. Do you guys see how we draw it? So you do like this, and then you draw little circles going outwards. That's how you draw polar coordinates, okay? So that's what we're going to be dealing with. And in these 4 pictures, we have some different things that we will be learning, not in this section, but the next section. A lemniscate, a rose curve, another rose curve where n is odd, and Archimedes' spiral. Aren't those beautiful? Aren't you pumped? All right, so we're going to start with the basics. So before we can graph these beautiful curves, we need to know how to graph the points on these curves. Okay, so every point in the polar coordinate plane is given by r comma theta. So r is the distance from the pole, so we don't call it the origin anymore, although I sometimes even slip up and call it the origin. So the distance from the pole, and theta is the direction that you go towards in that, like out that distance. Okay, so r and theta can both be positive or negative, which is very confusing. So like I said, that's the most confusing part of what we're going to do today, is that things can have like double negatives in math. Okay, so when I see 5 comma pi over 4, okay, I have made these polar coordinate grids very nice for you. I made it so you still have your 30, your 45, and your 60 just like normal. Sometimes when you look these up online, sometimes they have 1, 2, 3, 4, 5. All right, if they have 5, then it's including the 15 and the 75 as well. Okay, I'll try to keep them as the 30, 45, 60 because I think that's just much nicer for you guys. All right, so anyway, so I have, what it's saying is that my r is 5 and my theta is pi over 4. So this literally means I'm going to go along the pi over 4 line 5 units. Okay, so my point is going to be located along the pi over 4 line, that 45 degrees, right? 1, 2, 3, 4, 5 units right there. Okay, that's going to be my point. Do you guys see it? Do I need to draw it in another color? Can you see that? All right, now this next one is -3 comma pi over 6. Here's the pi over 6 line. That's it. We're just graphing a point. This homework is the easiest homework ever.
No lines.
No lines, just a point right now. This is the introduction to polar coordinates. All right, so anyway, so if we have this pi over 6 line right here, what do you think happens when our r is negative?
Go towards the opposite side.
It's going to go towards the opposite side. It's going to go towards what angle?
7 pi over 6.
Yeah, it goes towards 7 pi over 6. Do you guys see it? So it's kind of like you extend this line, but you also think about it going in this way. So it's going to go 1, 2, 3 units out along that line. Okay, so we don't draw all this mess that I'm drawing. We just draw the point in the end. Does that make sense? So in other words, this is equivalent to if I had just said 3, 7 pi over 6. So sometimes there's different forms because you go 3 units along the 7 pi over 6 line. Okay, so what if I have 4 comma negative pi? So negative pi. Okay, negative pi is when I go around in this direction. This is the negative pi line. So if you have negative pi, you're right there. So if you go 4 units along that line, nope, you go 1, 2, 3, it's right here, 4. Do you guys see what I'm doing? So think of it as negative 180 degrees. We went backwards to negative 180 degrees and we went along that line 4 units.
Couldn't it just be pi at the top?
It's actually the same as 4 comma pi in this case, yeah. Pi and negative pi are in the same location. All right, if you have negative 3 pi over 2. Ooh, it's getting tricky. Negative 3 pi over 2. That means we start here and we go all the way around to negative 3 pi over 2. So that's this line right here. Just drawing these lines to help you. We don't typically like draw those lines in, right? And then we're going to go back from that line 3 units. So now we're going to go, do we go up or do we go down?
Down.
We go down. Do you guys all see that? So we're going to go down 3. 1, 2, 3. And then we have 0 comma pi. So 0 is our r, pi is our angle. So here's where our angle is. But we're going 0 units along that angle. What do you guys think?
On the pole.
It's on the pole, right? So the origin, as we used to call it, is called the pole in polar coordinates. So it's right there. So it's just that single point right there. And then 3 comma 0. Ooh, how do we do this? This is saying 0 is our angle, right? So here's our angle, and we're going 3 units along that. Okay, 1, 2, 3. It's right there. Okay, do you guys kind of understand this? How to graph those points?
So if the
Yeah.
number
How can it be the same minus 3 and 3?
For minus 3 and 3, for which one? Oh, I'm just saying there's other ways to write it. So one way to write it is to say you have negative 3 comma pi over 6 because we didn't go along the pi over 6 line. Well, we went along the pi over 6 line, but we went in the opposite direction. We went backwards.
Yeah.
Okay? Or you could call this, instead of negative 3 comma pi over 6, you could call it 3 comma 7 pi over 6 because you're really going along this line, which is 7 pi over 6.
Okay.
Does that make sense?
There's
There's actually other ways. There's 4 ways to name this. Can you guys do that on number 2? What if I had called this a negative angle? So what if I went backwards? What angle would that be if it was a negative angle? Negative 5 pi over 6. So then you would go 3 units along the negative 5 pi over 6. Does that make sense? All right, and then what about if I had, so look at your different combinations. See how you have 2 positive 3s, 2 positive angles, 1 negative angle. What if I had another negative angle, but then I use a negative? So what negative angle would take me all the way around to here? I know it's hurting your head, isn't it? Negative 11 pi over 6. And then we would go along that line, we would go backwards, right? We'd go negative 3. So that's the 4th way of writing that. So there's always 4 ways to write any polar coordinate. Okay, annoying, isn't it? I always like when they're just positive. It's much more straightforward. All right, so maybe see if you can do 7, 8, and 9. So look at your paper, try to do 7, 8, and 9. Okay, did you guys get those 3 points? So the first one, you go backwards to negative 5 pi over 6, and you don't go along that line. Instead, you go in the reverse direction. Okay, so you go back 1 from that. So the easiest way to write that would be what? What's another way of writing this?
1 pi over 6.
1 comma pi over 6. That's kind of like the, I would say, standard one, right? Positive, positive. All right, and then if you have 2 comma 11 pi over 6, that means you have your 11 pi over 6 line, and you go 2 units along it. So do you guys have that 1 point right there? Okay, and then the next one is, that's the negative pi is always what was hard for me. I always got mixed up with the negative pi. So negative pi is the angle that goes back, like in the negative direction to pi. And then you go back 3 units along that. Okay, did you guys all get those 3 points? Do we like these? Okay. So it says name all of the polar coordinates that represent the point 3, 5, pi over 6. Okay, so we already did 3 pi over 6. So let's do 3, 5 pi over 6. So remember I told you there's kind of a pattern. We have a 3, we have a -3, and a -3. Okay? We're going to have 2 that are +3, 2 that are -3, and then we're going to have 2 positive angles and 2 negative angles. Okay? So let's think about it. If I have 3, pi over 6, I did not draw this well at all. 5 pi over 6 is going to be over here, and you're going to go 3 units along. Okay, if I talk about a negative angle, what negative angle would I have? Yeah, -7 pi over 6, exactly. Do you guys all understand that? So going back to that line in the negative direction. So that would be 3, -7 pi over 6. That's the first one.
How did you know those 7 pi over 6 again?
Because I'm going in the negative direction for an angle. Remember, negative angles go this way. So like if I said, draw -60 degrees. -60 degrees is right here. You go back 60 degrees from the x-axis instead of the positive direction, which goes this way. All right, so I was thinking, how do I go back to that same location as 5 pi over 6, but I'm going the other way? They basically add up to be 2 pi, 5 and 7 pi over 6. All right, and then here's the tricky ones, the negative ones. Okay, so the negative ones are going to be along this line right here, kind of the opposite way, right? So that line, let me kind of draw a new sketch over here. This line right here is going to be either -pi over 6, or what's the positive way of writing that? 11 pi over 6, exactly. So we have -3 can go in the direction of positive 11 pi over 6, or it can go in the direction of -pi over 6. Okay, so you guys see the 4 ways you can write it? It's a little tricky. All right, so find the rectangular coordinates that correspond to the following polar coordinates. Rectangular coordinates, we talked about that in the last chapter. That means it involves x and y. Okay, so we need to have x and y in our answer. All right, so let's sketch it out. So if I have 3, pi over 4, you guys are going to get to be pros at drawing this. Do 3 concentric circles like a dartboard, right? And you're going along the pi over 4 line. 3 units. 1, 2, 3. So you're right there. So if I want the coordinates x, y, as if I was in the Cartesian coordinate plane, Ben, Tyler. All right, how do I find it? Yeah, we know that it's normally like for a hypotenuse of 1, it would be √2 over 2, √2 over 2. Not quite on this one, almost. Yeah, it's going to be 3 times √2 over 2, 3 times √2 over 2. So kind of tell me how we can find this. Thinking of our favorite thing, SOHCAHTOA. We have our angle in here, which is 45 degrees, right? So let me draw it out bigger. So we have 45 there. And we know that our radius, our length is 3. So if our length is 3 and we wanted to find the x value and the y value, what we're doing is we're setting it up. We're saying, let's do the x first. We're saying that cosine of 45 degrees is equal to adjacent over hypotenuse. Oops, I'm doing 45 over 3. So it ends up being 3 cosine of 45. That's going to be my x value. Does that seem familiar? So we get 3 √2 over 2. And then for the y value, that's when we do sine. So we're going to say sine of 45 is equal to opposite, which is y, over hypotenuse, which is 3. So we end up getting 3 sine of 45. This directly corresponds to something that we learned in the last chapter. Do you guys remember what we were doing when we found that?
Slope and how much
Not the slope.
power?
The what? The component form of the vector. Do you guys remember that? So the component form of the vector was always r cosine of theta, r sine of theta. And we did our little vector symbols there. It's the same thing here. We're just doing r cosine of theta, r sine of theta. So that's the shortcut. Okay, so do we think we can do that for these ones? So we're going to have, this is our r, and that's our theta, right? So when we set it up, we're going to do r cosine of theta, comma, r sine of theta. It's always that way. So we're going to get 5 cosine of 5 pi over 6, 5 sine of 5 pi over 6. Okay, do you guys remember your unit circle? What's cosine of 5 pi over 6? Can you guys do it in your head? No? You need to see a sketch? 5 pi over 6 is here. So you go to the left, root 3 over 2. You go up 1/2, so you have 5 times 1/2. So your final answer is negative 5 root 3 all over 2, comma, 5 over 2. Okay, these are involving what we call exact values. These are unit circle angles, right? We have 5 pi over 6, we have pi over 4, we know these. 3 pi over 2, we know that. All right, so if I'm setting this up, it's going to be r, which is 3 cosine of 3 pi over 2, r sine of 3 pi over 2. So we get 3, what's cosine of pi over 2, or 3 pi over 2? 0, right? Do you guys need to sketch it out every time? Need to see your little mini unit circle. And then 3 times negative 1, right? So we end up getting 0, comma, negative 3. Okay, let's think about why this makes sense. Sometimes if you just kind of sketch it out, it makes sense. 3, comma, 3 pi over 2. Think about our polar coordinate graph. Like that. We're saying go 3 units in the direction of 3 pi over 2. It'd be right down here. Well, what point is that in a rectangular coordinate plane? Isn't it just 0, negative 3? Do you guys understand that, how they're related? All right, and then this next one, we don't have, like we have 10, comma, 5.2. This is not a unit circle angle, right? 5.2, what is that? I shouldn't really say it's not on the unit circle. It is on there. It's just not one of the ones that we have memorized, right? So we're just simply using our formula. So we're doing r cosine of 5.2, r sine of 5.2. What do you think 5.2 is? Do you think it's radians or degrees? It's radians. There is no degree mark. So it's actually radians. I know you guys don't like that when it looks like that, but. So if you have one of these, then I think I wrote on your homework, round to 3 decimal places if it's not a unit circle one. So 4.685. And then when I do 10 sine of 5.2, I get negative 8.835. And if you wanted to see what the picture was, I mean, I'm not going to do 10, but 5.2 is going to be, is that more than pi? It's more than pi, right? Pi is 3.14159, blah, blah, blah. Oh, it's March now. Ooh, I need to pass out Pi Day information. Very exciting. It's my favorite month. Not really. I always make this sound like it's my favorite holiday.
Do we get pie?
Someone has to bring in a gluten-free thing, otherwise I might cry. I'm on a gluten-free diet for my pregnancy. All right, anyway, so 5.2. So 5.2, is that all the way to 2 pi? What's 2 pi? Yeah, 2 pi is at 6.28 would be in the radians, right? So we're in between pi and 2 pi. Well, what about 3 over 2 times pi? So 1.5 pi. That's 4.7. So we're in between 4.7 and we're in 6.28. We'll say 6.3. So it's somewhere in between there. So it's definitely in the fourth quadrant. Does that make sense? That's why it's a positive value and then a negative value. And you would go out 10 units along there. I'm not going to draw it out with 10 units, but that's what the sketch would look like. All right. Last little bit. So find the polar coordinates that correspond to the following rectangular coordinates. So think about the quadrant. Does your angle make sense? If not, adjust your theta. Okay, so you should always think about the quadrant. So in this case, I have root 2, negative root 2. So I'm going over here, and then I'm going down here. Okay, so I want to find the polar coordinates. I want to find the angle, and I want to find how long the radius or the r is. Okay, so thoughts. There's an easy way to do it. It's definitely like negative 45 degrees, right? Or you could call it what angle if it was positive? 315. 45 subtracted from 360, so you could call it 315. Okay, but what about your radius? What about this length right here? How do I find that? Yeah. So I'm going to do r squared equals root 2 squared plus negative root 2 squared. So we end up getting 2 plus 2. So r squared is 4, so r is then 2. And then theta, you guys got really easily. You could tell that it had to be 45 degrees there. Like this one had to be 45 degrees. So you knew that our angle going all the way around had to be 315 degrees, okay? I didn't tell you to write it in radians or degrees, did I? Let's do radians and less specified. Got to get you prepped for AP Calc if you're going to take AP Calc. So 7 pi over 4. All right, so sometimes they're not that nice. So this next one is actually a unit circle value, but you probably don't recognize it as a unit circle value when you draw it out. So this is positive root 3, and then it's negative 1. Yeah, it ends up being like, you can kind of see it's the 1, root 3, 2, like the 30 is in here. It ends up being 11 pi over 6. But if you didn't see that, then there is a way we can find it. Our formulas are these. So r squared is equal to x squared plus y squared. That's the first thing we use. And then tangent of theta, just like vectors, it's the y value over the x value. Good. Yep. See how this chapter is very related to the vectors? I almost made it one giant chapter, but it just seemed too much. So I decided against it. All right, so let's start with the r squared equals x squared plus y squared. So we get root 3 squared plus a negative 1 squared. So we get 3 plus 1 is 4. So my r is equal to 2. And then my tangent of theta, if I do that, tangent of theta is equal to the y value over the x value.
Is r always going to be 2?
No, wouldn't that be nice? And we do inverse tangent. You can put it in degree mode because I think you guys are more comfortable with that. So you can do inverse tangent of negative 1 over root 3. So we get negative 30 degrees, which makes us know that it's right there, which is good, right? Because we always have this sketch. Does that make sense with that? We're good. So we're going to call it 11 pi over 6. Okay? So our theta is going to be 11 pi over 6. So I really haven't written this. I need to do my final step. I need to write it in polar coordinate form. So it's always r comma theta. So r is 2, theta is 11 pi over 6. So on the last one, it should be 2 comma 7 pi over 4. All right, do you guys understand this? All right, some of them you don't need to do a lot of work if you just think through it. You got to be smarter than the piece of paper in front of you, okay? So you have 0, negative 7 root 2. Sketch it out. Over 0, down, negative 7 root 2. So think about how you could write the polar coordinates. If you had something like this, what would your r be? You could do negative 7 root 2, or you could do positive 7 root 2, right? Let's do positive 7 root 2. What is your theta? 3 pi over 2. Do you guys get that? You're going along the 3 pi over 2 line, 7 root 2 units. So sometimes you can just do it. You could do the formulas, though. If you get stuck, do the formulas. You'll get it. All right, and then this one is one that we definitely don't know these angles. So we have to do the formulas. All right, so I have negative 3.5, negative 1.2. So let's find r. So we're going to use r squared equals x squared plus y squared. Ben, Tyler, stop. I put this in. So I get r squared equals 3.7, so I take the square root, and we'll round to 3 decimals. So we're going to have 1.924. Did you guys get that for r?
No. I got 3.7 as R.
R squared.
Okay.
So then take the square root, yeah. Like a squared equals b, or c squared equals a squared plus b squared. All right, so then we're going to do tangent of theta.
I still got 3.7 as R.
We'll take the square root of it. What'd you get when you take the square root?
Well, negative 3.5 squared plus negative 1.2 squared equals 13.69, which is R squared.
Oh, I see what you're saying. Okay, yeah, you're right. Thank you. I already took the square root.
Yeah.
Is that what you're saying?
Twice.
Extra point on that.
She does get an extra point, that's right. All right, so r is equal to 3.7. And then when we do our tangent of theta, so we're going to have tangent of theta is equal to negative 1.2 over negative 3.5. So we're going to do inverse tangent of whatever that is. Running out of room here. So we end up getting theta equals 18.925. Okay, is that what it looks like? Yeah, this is why you should always, always, always draw a picture. And some of you guys missed some points on your tests because of this, because you didn't sketch out where your vector was. So when it came to finding the angle, like the direction angle for the vector, you got it wrong. Because sometimes you have to add 180 or add 360 or whatever. So we are in the third quadrant. So 18 is like that angle right there. Okay, we don't want that angle. We want to find the angle on the other side in the third quadrant. So we're going to add 180 to it. So our theta actually ends up being 198.925. Okay, and I guess if they're weird, if they're not like unit circle ones, I'll let you leave it as degrees. Okay, so you can do that. So it's going to be r was 3.7, and then theta was 198.925 degrees. Okay? All right, does that section make sense? Does anybody have questions on any of that? Good to go?